I have just disassembled both units and found the failure is quite simple. It seems like a typical fault. I will take it apart for you all to inspect closely. Let us examine the defect right here. I opened one. It is sealed with glue. This is the core structure. Please pay attention here. The two AC input wires from the base lead to these pins. Notice they have completely detached. It appears as if something is pushing them upward. Why did this detach? Another one is also detached. This one has less detachment. Look. Let me show you the location of the failure. This one is fully detached, while this one is cracked. Just a small crack. So why does it experience such detachment issues? The client says some lasted a while, others failed quickly. Some units failed after just a few days. This is a 20W bulb, though likely overrated. When running, the LED array lights up and generates significant heat. Even modern LED bulbs, they get hot. Perhaps the customer leaves them on all night. Used in restaurants, they stay on constantly. Continuous operation causes them to overheat. The LED gets hot. It is due to poor manufacturing solder quality. That is why it detaches itself. Excessive heat melts these solder joints. When repairing, we can simply inspect these units. Resoldering can often save them from disposal. I will test resoldering one now. I notice the internal wires tend to keep popping out. Everyone please note, it happens because it is too hot. The factory solder joints were poorly designed. Consequently, heat from the operating LEDs causes failure. It becomes very hot. These solder joints eventually break off. These joints supply power to the bulbs. It is quite a common failure. I am not sure if the third one has a zero fault. I will disassemble it. Let us inspect it. This circuit here. This circuit, it has an AC input voltage, 220 volts, and it passes through this rectifier bridge filtered by a 400 volt, 4.7 microfarad capacitor. The 300 volts energy from this capacitor powers the stage. It flows through a buck converter step-down circuit to produce an output. Using this specific control IC, a rectifier diode is included, and an output inductor. It steps down to a stable DC voltage. Input voltage varies within its operating range, likely from 180 to 260 volts AC. It maintains a stable output. Powering the LED string also, it uses the voltage drop for current regulation. Across this specific 1R6 current sensing resistor here, this resistor component ensures stability regardless of total LED count. Variable LED loads. The voltage across this resistor monitors the current, keeping the LED brightness at a stable level. Observe that. It is a constant current circuit. I just soldered this component. The solder joint is solid. Now let us test it. I expect it to work properly. I will utilize the lamp base connector to connect this light bulb again. Let us see if it lights up. See, it is lit now. Very easy indeed. Do not throw these into the trash. Same goes here. I can resolder this easily. It detached. The next one. Is this one broken too? Yes, same issue here. That is a common defect. Wonder about the brand, Super brand, Euro Super. Do they even know? Do they know their solder joints fail? Are they aware? All fully detached due to heat. The LED strip generates constant heat. It accumulates on the aluminum. High temperatures transfer through, melting the solder joints, and these contact pins tend to push. Internal wire, rigid wire, it exerts constant downward pressure. Once assembled, the constant pressure causes the failure, pushes it down, thus it peels off. I can fix this easily. Let me try soldering this one to check results. Throwing this away is wasteful. Such a waste. Reduce environmental waste. I will solder it firmly. It will stay fixed. This is due to wave soldering. Insufficient solder on the joint, poor wetting of solder, or possibly low heat caused poor flow or excessive solder flow. Watch closely. Let's test. Check if it lights up. See, it lights up perfectly clearly. Install this part. It glows very brightly now. Let us examine it. Those three are quite simple. Checking the bulb, Sunhouse brand bulb, find the fault here. To repair this Sunhouse bulb, let me rotate it to take a look. Checking for burnt lead chips. Using the multimeter, I tested it already. The chip rating is likely 6 or 9 volts. It is 9 or 6 volts, set to 10K range. Use 10K range. Voltage output is 12 volts total. I can measure it. It will light, not very bright. Testing for your reference now. It is not detached at all. Solder joints are very solid. Testing all contacts, checking every single LED strip segment. This one lights up. 12 volts limited by a resistor, so the LED won't burn. It glows dimly. We can test it, check the LEDs, test one string, find burnt LEDs. One usually burns. Stops shining. Regarding the popular bypass tip, Common YouTube advice. They suggest shorting it out. I will explain, for reference, this bypass mode, how it works. Why it short circuits, burns quickly. Watch out, none look burnt. Oh, this one failed. This segment, this glows too. It is faulty. This lead is damaged, marking this unit. Wait now, right here. Found the broken one. Faulty part. Repairing it is very simple, very easy, so easy. I will just short circuit the contact point, bypassing the failed lead chip. Removing burnt lead. The circuit will work normally, however, we must understand why after bridging we just utilize it will be burn out quickly because the lead shade, notice this, it turned brown already, the brightness level has dropped significantly. Lead lifespan limit has a limit. In summary, this lead burns. Other LEDs too have similar light lifespan. Other diodes are also worn out, therefore we solder this, just for temporary lighting, temporary usage. Truly speaking, for durability, we must reduce voltage or lower current. Here is the driver circuit, designed like my previous analysis. It will have a resistor here, not using 1R6 anymore, it is 2R0. It uses the voltage drop across the 2R0 resistor. On this 2R0, to stabilize lead current, now we increase this resistance value. For instance, 2R0, I am taking, add another 0.22 ohm, connect it in series, or increase resistance. Say to 3 ohms, this will result in the supply current for this IC, self-adjusting output, the pulse train, regulation pulses, it will provide less. Output current for the lead strip. Providing lower output, the light will dim, dimmer light output. Take this bulb, its rated power is about 20 watts. Now let's reduce it to maybe 15 watts or just 10 watts. It may last longer. Much more durable. Now I will try soldering. Check the light, then I'll perform assembly test for durability. Verify the calculation. Overall component lifespan. We are exploiting lower output. At reduced brightness, it could increase longevity. Total lifespan, like these burnt bulbs that already failed here. Other lead units, those similar units, they have had the same total operating hours already. If they have, it's failing. Like TV LED backlights, standard TV LED strips. One is burnt, others will fail soon. Take note, bypassing isn't durable. This design is poor. Removing the aluminum heatsink is difficult. Let's try prying it. It's really stuck. Shorting it. Shorting now. Testing the connection. Measuring the output. Checking continuity here. It is working now. Now I test. Check brightness. It should shine. See that glow? Very bright. It just lost a few LED diodes. Still bright. Bright as before. Let me check. Getting my digital multimeter now, showing the values, checking power, using this meter, measuring current, this old meter. Bought it early, the whole unit. Cost me around 260 kV and installed in panel, left unused. It's malfunctioning now. This power meter features that it measures power for our testing. I will measure these LED bulb wattages to check accuracy, and I will test reduced power, check the output levels. Right now, I have a bulb, a 75 watt incandescent bulb. I'll test this for you, checking the 75 watt rating. For precision, I will install it now, and here, I simply short-circuit these terminals, which means 220V powers the incandescent lamp. I'm shorting them, so let's observe readings. The 75-watt bulb shows around 78 watts, 77 watts is acceptable. Because filaments have some tolerance, everything is working correctly. And next up, I will test this LED light bulb labeled as 20 watts. To check accuracy, not soldered, let's use this one. The repaired unit is also 20 watts. Let's check this reference. Verify the power rating. It shows just about 13.6 watts, only 14 watts total. So this unit, this component is not actually accurate here, this specific item. Same thing here. I have just tested. I soldered 2 units. It holds that value only. However, this one is 20 watts. This lamp is 20 watts. Where is the label located? It is specified 20 watts rated power. This Sanhao unit. 20 watts, and check the operating voltage range, 130 volts up to 260. I will test this now, confirming 20 watts total. I am currently connecting. Testing one lamp unit, assumes 20 watts, showing for everyone. So now, measuring current. Can you observe it? It reads 19 watts. Please watch at 19 watts reading. This specific lamp has one faulty LED diode. Since it's paralleled, to improve, to enhance durability, as previously mentioned. Before that, we must reduce current, the load, for instance 19W, limiting to 15 watts. It boosts durability. Since it's parallel, to effectively lower its total power output, we'll modify that. 2 ohm resistor, it uses the sensed voltage drop. The IC senses drop to stabilize current. We increase the resistance value, so the voltage drop, applied to IC rises. This will reduce current draw. Let us verify this theory. The 2R0 resistor will become a 3R. Testing now to observe if it decreases, locating the component. Found a pack of resistors at 3.3 ohm rating, and I will replace the stock 2 ohm with this 3.3 component, using a 3.3 ohm part so that the sensed voltage drop across it increases. It feeds back voltage. This IC will reduce the current consumption, power consumption. For LEDs, it regulates voltage. For LEDs, stabilizing current with lower voltage, lower levels we can apply, repairing various LEDs, works well, Firefly or similar bulbs, we just need to intervene to effectively reduce the lead current draw. So look here, before it was 20W. Let us check now. I am using a tester, a simple shorted socket, to measure 220V input on the bulb that I am repairing, and right now, look, we can see it has dropped down to just 12 watts instead of the original 19 to 20 watts as before. Therefore, this method of modification allows us to repair it, avoiding high current draw, excessive current load like the original factory specifications because the LEDs are aged. Many viewers of the channel often ask me questions. Just proceed, follow instructions, replace the LED slowly, output power remains stable here, lasts 3 times longer, avoid another LED failure using this specific method. Our processing technique here. Avoid overdriving the LED at higher power levels. This bulb rated at 20 watts. I have reduced it down to 12 watts. Brightness will decrease, slightly dimmer, but significantly improved lifespan. More durable, it prevents recurring failures. This serves as a solution for conservation, repairing these specific LED bulbs. Just these LEDs, using this expert's trick, I have repaired many units, television sets, especially Sony models and LG units with those LED strips back in time, years ago, about 5 to 6 years. Sony LED units were very expensive. I manually intervened on the line, managing current resistor values. Circuit knowledge helps to successfully reduce the total LED brightness output. We can reuse these old LED bulbs, despite their degradation, still functional, durable for use, as you know in this video. I shared a technique, a repair tip to troubleshoot issues on various LED bulbs, specifically the units here I'm repairing now, though these are basic devices, very inexpensive once we understand circuit design and how the circuitry functions properly. We can modify them and extend their lifespan for usage. So therefore, these 4 bulbs have all been fixed for the client regarding this specific bulb. Burned out LED, I reduced from 20 watts down to 12 watts, but it remains bright, surprisingly bright, and quite durable, unlike what you see on other channels, other YouTube channels. They always instruct when finding a dead LED bulb. Using a multimeter to locate the failed diode, just bridge the contact. It works. It burns within days. Take note, using my method, I analyzed the circuit logic. I successfully reduced its current. Lowering idle draw. Specifically, I capped the power. This LED no longer glows intensely bright. Its output is slightly dimmed, which extends its operational lifespan. I will wrap up this technical video right here. If my content helps, stay tuned. Please like and subscribe to keep updated with my upcoming electronics tutorials. Goodbye, everyone.